Okay, so as I mentioned, welcome everyone for joining our CDW and HPE webinar today on the impact of AI and ML on the financial services. First and foremost, I'd like to introduce myself. My name is Brian Matthews. I'm a senior manager on CDW's solutions team, and I have responsibility for a group of individuals that are vendor agnostic solution architects across all major architecture areas, so infrastructure, security, data center, networking, and I'm part of a larger CDW pre-sales organization which helps customers every day find the right solution to solve their challenges and deliver business outcomes for their business. So I will be your host for today. I've got a couple quick housekeeping items and a couple quick slides, and then I will pass the microphone over to the star of the show, Jordan Nanos. So with that, let's maybe just go over the housekeeping items and then we'll kind of dive in. So first and foremost, the Q&A box is live. So if you have any questions throughout the presentation, feel free to throw them in the Q&A. We've got some time dedicated at the end of the session to address all questions. If there is something that maybe pops into your head later today or tomorrow and you want to have a follow-up conversation or a discussion specific to your business and your needs, feel free to reach out to your account team. So your account executive, your account manager, or any member of the CDW team, and we can definitely set that up and have some subsequent conversations. Probably most importantly, for anyone that is in the GTA and is on the call today, there will be a cookie drop. So cookies, from what I am told, will go out next week. So hopefully it brings a little bit of a smile to your face or your family's face to have some delicious, fresh cookies as part of joining the webinar. So let's kind of dive in. If we can go to the next slide, please. All right, so I'm just, as I mentioned, going to spend 2 or 3 quick minutes talking about CDW. For anyone that is unaware, there has been a lot of evolution and a lot of really exciting changes going on at CDW, not just over the last couple of years, but over the last 5 or 6 years. I've been at CDW 13 years, spent most of that time in the sales organization as an account manager and then later as a sales manager, and really excited at where we are today and are now our capability now to serve our customers better than ever before. So we are the leading IT solutions and services partners, integrating and managing technologies to help customers achieve their outcomes. If we go to the next slide, it will really hopefully articulate a little bit of the evolution that I discussed earlier. So there's lots of different milestones on this chart since we were founded in 1984 in Chicago. But one of the things that I think is most important is the strong financial performance of CDW. So as you can see, we consistently year over year grow our annual revenue, usually double digits. We try and outpace the market by 2 to 3x. And that's just part of CDW's DNA. We are a Fortune 200 company now, so we've been, at last count, I believe, number 189 on the Fortune 200 list. And that financial stability allows us to make very strategic investments into our business. So if you look at not only, in the top right corner there, the Scalar Decisions acquisition that was made in 2019 and, has really ramped up a number of areas in our Canadian business. But even more recently, we announced an acquisition of a company called Aptris, which is one of the top ServiceNow partners. So that is now part of the CDW family. And then even as recently as Canada Day, we got an announcement from our CEO that we've made 2 subsequent acquisitions. So one is a company called IGNW, which is a leading provider of cloud-native professional services based out of Portland. They do, advanced infrastructure automation, modern cloud practices, big data, AI and ML, app modernization, and software engineering. So again, just some really deep expertise that we're adding into the family. And then also on Canada Day, a subsequent acquisition that came through was a company called Cloud39, which is a specialist in data orchestration, machine learning, and modern application development. So I think what you've seen from CDW is, in our early years, we were very much a sales organization, a marketing behemoth. We built, customer relationships at scale, all over the world. And now via acquisition, we've added deep technical expertise. And we'll talk a little bit more about that, how it pertains to Canada. So next slide. This is really our global value statement, right? This is who we are in a nutshell. when we think about that size and scale, over $18 billion of net sales in 2019, 250,000 customers, so 250 million customers globally, about 30,000 actively buying customers in Canada, to give you that contrast, and close to 10,000 global employees, with about 1,000 of those being in Canada. Next slide, if we talk about what it looks like, right? We call it the Great White North, 900 plus coworkers. Over a third of those coworkers are in technical roles. So our ITS is our Integrated Technology Solutions, which makes up both our pre-sales technical group and our delivery and services and managed services groups, both in our SOC and our NOC. So over a third of our employees are technical in nature, again, to help our customers solve those complex problems. When we think about the merger with Scalar Decisions and CDW, there's three things I would highlight that I would probably ask you or just challenge you to think about in terms of the new CDW and what we can bring to the table. First and foremost, we used to have one office at CDW based out of Etobicoke with field resources scattered across the country. Now with the acquisition, we've got 10, I think it's 10 offices, it says 9 on the slide, but almost double-digit offices all across the country. And that allows us to meet our customers where they are. It allows us to be local. And the resources that we have, whether it's in Edmonton or Vancouver or Montreal, they're not just salespeople. We have technical people there as well for pre-sales and delivery. Another thing I would call out is our services practice. In CDW's old go-to-market strategy from a services perspective, it was all done through third-party ecosystem partners, and with the acquisition, we brought on a large and very mature services organization. Again, both from a professional services perspective, on the security side, we have risk advisory services in terms of penetration tests, vulnerability assessments, any other security challenges that you're having. And then we also have a SOC based out of downtown Toronto and a NOC in Calgary to do our managed services for customers coast to coast. So hopefully this gives you a little bit more on who the new CDW is, what we can bring to the table. If you have questions about any of the new capabilities, any of the new expertise that we have, again, I would encourage you to reach out to your account team, whether it be your account executive, your account manager, and set up a subsequent call with myself, another member of the team, another member of our security group, our infrastructure group, whoever it may be. So with that, if we go to the next slide. I think we might have skipped ahead too, but I will let our team work on that. At this point, my job is over for the next little while. Again, I'll be looking at the questions coming in the Q&A, but I have the great pleasure of introducing Jordan Nanos. So Jordan is the lead architect for high-performance compute and AI at Hewlett-Packard Enterprises. He's someone that I've worked with closely over the years, and really excited to hear from him today and get some more perspective on what he sees in the market. So without further ado, Jordan, the floor is yours.
Thank you very much, Brian. It's my pleasure to be here with everybody and appreciate the introduction. I'm going to jump right in because it seems like we're missing a little title slide there, but I'm sure everybody's more interested in the content anyway. So yeah, I'm going to be talking about in this webinar, a little bit about the impact of artificial intelligence and machine learning on the financial services industry. I'm going to try and do this from the perspective of end users and in both the IT organization who are managing systems and dealing with the new demands from users external to IT, as well as in some cases from those users' personas, to try and figure out exactly how people differ in the world of machine learning than in traditional IT contexts. Just to start off a little bit, I want to introduce who HPE is in high performance computing today. So much like the slide previously from Brian, showing a bit of a timeline of where we're at. The story of HPE in high performance computing starts really in 2008, but on the timeline here in 2014, when we introduced a line of servers we refer to as our Apollo servers. At this time, people were using the term hyperscale to really talk about new types of architectures that were coming along that were bigger than anything that had been seen before. Many users in the industry will argue about the definition of hyperscale. We refer to it more as an era, not necessarily a technical definition to say how many servers were in a data center or not. But it basically was an evolution because all of a sudden, the use of software-defined storage, software-defined networking, commodity servers were becoming more and more a part of enterprise data centers. And this is both in the context of people building clouds, as well as in some cases, service providers and IT taking a shift within some of the largest institutions in the world, primarily in financial services, to providing infrastructure internally as a service, acting as a service provider to many different lines of business. As we continue to go through to today, HPE has made a number of strategic acquisitions that I'm going to talk about during the course of this presentation. Specifically, companies such as Silicon Graphics in November of 2016, Blue Data, which is now branded as the HPE Container Platform, and an enterprise container platform that's been around since really since before Docker Swarm, before Mesos, and of course before Kubernetes. In August 2019, acquiring MapR to provide the new product that we're coming to market with is the HPE Data Fabric, a scale-out, really high-performance file system and ecosystem for big data analytics workloads. And finally, and something that we're most excited about, in just January of this year, we closed on the acquisition of Cray, company building the largest supercomputers in the world. And that really brings us into what we're referring to as the exascale era going forward. So where in the past we referred to things as being in the realm of hyperscale, exascale is 2020 and beyond for a number of different reasons. First of all, the systems that Cray will be delivering, we will be delivering at the end of this year, are going to be the largest supercomputers in the world and be able to compute one exaflop, over an exaflop, which is 10 with 18 zeros behind it, one with 18 zeros behind it, a new era of computing power. And some of the technology that's behind that is going to really influence what we talk about today. So I wanted to start with this slide to just say who's HPE in HPC, in high performance computing, and then really let everybody on the phone know that we are doing something interesting at the top end of supercomputing in the world, while also bringing that technology to users downstream who may be interested in it. So let's start by talking about some of the trends that we are seeing in this industry and how it may impact some of the IT decisions that are being made. I'm going to talk about this from the perspective of high performance computing, and I hope that many of you will see a similarity between what I talk about here and what you're seeing in many of your daily activities today. The first one is the evolving space of new processors. We've seen a lot of explanations why Moore's law running out and Dennard scaling really ending is having no impact on the performance of many applications. And these explanations take the form of specific processors built for specific workloads, things like GPUs being used for neural network training, next generation CPUs that are packing more and more cores onto a single chip, as well as many other technologies that are dedicated to deep learning, training, inference, using old technologies like FPGAs or newer technologies that are more closer to what people will be familiar with as an ASIC. We've referred to this trend as in processing as being a change towards hot and heterogeneous, many different types of processors, and they're only getting hotter. They're only consuming more and more power over time. In addition to that, we've seen many different overlapping spaces of work happening. So in the traditional world of high performance computing and research, higher education, federal governments, things like that, simulation and modeling was the primary workload. You take a lot of compute, you hook it together with a really fast interconnect. The compute runs jobs in parallel that can be broken up across all of the different compute elements. And a huge amount of storage, data storage is required to persist the answers, the simulations, the models that have come out of some of these workflows. And this could be, related to any of the many different areas of science that benefit from high performance computing, things like computational fluid dynamics, finite element analysis, molecular dynamics, from chemistry to biology, in some cases to traditional finance, what we used to call quants or quantitative analysis. It fits into this category of simulation and modeling. However, if I describe the architecture of simulation and modeling, a lot of parallel compute, a fast interconnect, and tons of storage space, that seems very similar to what we've been building to store data and do analytics on it in the world of Hadoop, in the world of big data, what people have been using for years, over a decade now, to build out data lakes and advance the analytics agenda of their business units. This could be for marketing, it could be for risk, it could be for customer engagement, many different areas that could be relevant in the world of big data analytics. And the most new area of this this trifecta is what we're calling artificial intelligence. The idea being that we're going to take many of these hot and heterogeneous processors, churn through a whole bunch of data, and come out with a really lightweight model at the end, almost the opposite arrow of how simulation and modeling was flowing. The result is that we've got this huge space of data-driven workloads, where we have this confluence from people coming from the space of Hadoop, who are used to lots of data, petabyte scale data lakes. We've got people who are just experimenting with artificial intelligence. It's being taught in all of the universities these days. Machine learning is influential on research across the wide spectrum of work that's being done. And then also involvement of traditional ways of approaching high performance compute in supporting the workloads of simulation and modeling. The other major trend that we're seeing is people's consumption habits, how users are actually interested in consuming infrastructure. So of course, we heard the terms as a service. To us, this is two different types of as a service. One is the subscription model, the Netflix, the Spotify, having a recurring bill, while others are used to being able to click around. I mean, Brian mentioned ServiceNow earlier, a perfect example of an as a service experience where people are able to send in requests and get a self-service experience. And we see this impacting big data, simulation modeling, as well as artificial intelligence, where people are looking for cloud native technologies like containers to let them stand up environments quickly, get access to data quickly, and then move on with their work. The fourth area that we see, major trends happening in is the, increase in other processing elements and data storage elements, things like memory moving on to the CPU bus with high bandwidth memory and archive data now not going to tape and moving to disk and the typical high performance flash SSD or with an NVMe interface. Okay, so now let's get to the topic of the webinar. How does these trends actually manifest themselves in the space of the financial services industry? And we see a whole bunch of different buzzwords from, evolving regulatory frameworks at the top, on the front and center of many of the decision-making processes that IT is going through today, all the way down to robotic process automation. The idea there being that we're automating away a lot of the repetitive cognitive tasks that in the past were handled by humans who are prone to errors and yeah, in many cases not getting the job done in a timely manner. In the technologies that enable these could be anything from alliances and consortiums to the big topic from today, which is artificial intelligence and machine learning. I'll start by talking about a few examples of what we're seeing and try to apply them to retail banking, capital markets, and insurance, really the three prongs of the financial services industry from our perspective. Within this area, I'm going to focus on three clear use cases that are head and shoulders above the rest in financial services. The first is related to marketing. The second related to sales. Many times they're treated as the same. And then the third being risk. So let's dive into a few use cases to start off with what we're seeing at HPE today, how we're helping our customers address these challenges, and then we'll talk about some of the technology that's underlying them afterwards. So the first is related to marketing and sales. And this is really, you know, a horizontal use case. It's not necessarily focused on the financial services vertical directly. Many different customers are engaging us for help with their marketing and sales applications. And the big reason why is that everybody's looking to retain their existing customers and grow their client base by attracting new clients as well. Specifically, the solution approach that we've taken in this space has been a partnership with a company called Data Robot for one part of the data pipeline that's required to actually, test and then deploy algorithms that are useful for something in the space of customer retention and upsell. It's either, saving money or making money, right? So in some cases, there in the marketing space, there's a metric referred to as cost per lead. And in this case, using an automated approach and focusing in on clients that are targeted and are going to have a much better response to marketing materials is hugely beneficial way to reduce the cost per lead. In addition to that, being able to take machine learning techniques and then actually apply them to your existing customer base to identify who is likely to be searching for a competitive offering compared to what you're offering today is important. Underlying the table, you'll see this right in the middle, this data pipeline. It's really an important concept, and the one that the HPE and Data Robot solution really addresses in this case is focused on customer retention, right? So the ability to ingest data, pre-process it, apply analytic models, so things like neural networks or basic machine learning models to promote certain outputs to users on the visual analytics side. It's this constant flow of data that's happening in real time, coming from a whole variety of different sources. It could be click streams on a website, it could be existing data that you've got in your Hadoop data lake for long periods of time about customers' historical trends. But the output is to provide people with some sort of actionable insight and then allow them to provide feedback to the model. Did this work or did this not, based on the promotion or demotion of certain signals. The second use case that I'll talk about here is related to credit risk and specifically alerting. So again, it's a real-time use case where people need to take action in real time. It's not done in a batch like we've previously done in the world of big data analytics, where reports are run based on what happened last month. How much did we sell last month? In this case, lines and loans are being, assessed in a real-time way, right? They're needing to be provided back. Answers are needed to be provided back to users in real time in an interactive way to determine if something's high risk or not. And it doesn't necessarily benefit the user if they can get that answer a week or a month later. It needs to be done in real time. So again, the input data could be coming from many different sources. In this case, the solution that we provided for many different retail banks is actually a warning module across things like credit cards, auto loans, and personal loans. And there's a set of pre-configured reports that can be run on the tool. This one is through a partnership with a company called AXS, and we actually build these solutions kind of end to end. Again, taking traditional data from sources like DB2 or SQL Server or your Hadoop data lake, and bringing them together such that users can run a pre-configured report and drill down into it, depending on which action they're trying to take across that loan. The third use case that I'll talk about here is a partnership with a company called Tukataki, based out of Singapore. And in this specific one, it's about fraud. So fraud detection and anti-money laundering. It's a much more specific use case to financial institutions that are at risk of financial crime. And it bridges the gap to something that we hear a lot about in this space, which is regulatory requirements, right? Being able to take an existing system that's in place to, you know, thanks to regulatory requirements, and then perform an extension on it such that you can get ahead of the competition and actually fight financial crime instead of running reports to show that you are compliant in the actions that you're taking, can save people money on their bottom line. In this space, you know, the banks that we've worked with have integrated this with existing tools, Spark and Hive, that are, you know, from the traditional Hadoop ecosystem, as well as new things in the machine learning space. For example, Data Science Studio, a product from a partner of ours called Data IQ. But again, we'll see in this space that the amount of data that's actually required to perform some of these tasks is immense, and building a you know, a real infrastructure that can support that data is among the first and most important things that you can do, such that one of these use cases can scale. And frankly, that's not just a point about, you know, point number 3 with fraud. It's a point that we see in the world of lending, as well as the world of customer engagement, where, you know, in many cases, data scientists, people that are joining the organization, can come up with really interesting new models, new algorithms in a sandbox. They can do it at a really small scale, and with a little bit of data. The problem becomes scaling this out to the entire enterprise, growing this to a space where users can actually interact with the platform, where users can provide change requests, and the creators of the models can actually test them to see if there's drift that's happening, or if there needs to be retraining that's done, or if overtrain's happening. Anyway, the point is that in many cases, building a resilient infrastructure from the start is what we intend to do here, for this use case in particular. The point number 4, you know, I think really we're making the point about the fact that the trends in this area, and, you know, credit underwriting is really no different, but the trends in this area are that things are shifting to real time from batch reporting because people need answers right away, and that building a resilient infrastructure from the start is a really important way to make sure that the project succeeds. In this case, the data that came out of these types of use cases that we've seen from the Hadoop space, it's not on the slide, but it's a analyst report from Gartner, was that in 2016, there's a prediction made that roughly 60% of these projects would not actually make it into production over the next 2 years. Things that were being started in 2016 would not make it to production by 2018. When Gartner went back and did an assessment, see if their prediction was correct, they found that it wasn't 60%, wasn't quite 60% that didn't make it. It was actually 83% of all projects that have started in this area did not actually make it to production. And the number one reason was that cost had run out of control. So just getting off the ground and getting started is a really important thing, but having the end state in mind, having an end game in mind, is a really important way that HPE can, you know, bring some value to the table. And with partnerships like the one with PRM FinCom in this space for credit underwriting, we can actually support that resilient infrastructure, having been through the experience before, and knowing the ins and outs of it, how to provide it. In this space, you know, an additional thing, if, you know, in many cases, these use cases related to underwriting have actually been deployed, and the improvements on them that we're providing with this platform is actually to reduce the turnaround time and then start to explore next generation use cases. Specifically at the application layer, we've seen that users are looking to explore, you know, new data sources that are related to natural language processing. So being able to take an existing model, an existing framework of how a decision gets made in this space, and then add in extra information to make the decision maker, not necessarily replacing the decision maker with an automated process, but giving them more information, whether that's coming from a PDF file or that's unstructured and is somebody's natural language inputs into a questionnaire, or if it's actually extracting it from a structured data source, such as a balance sheet or an income statement. Okay, so let me take a breath here. Hopefully that those use cases are something that's relevant to what you're seeing in your space and what you're hearing from peers across the enterprise. What I want to do now is take a step back and talk a little bit about the underlying infrastructure that actually enables some of those use cases and where there's actually common elements, despite what people are going to tell you about their really specific use case that's only great at fraud or client engagement or something like that. We can actually break it down into a generic framework that we refer to as a data pipeline. And the joke that I have on screen here is that this is much like a traditional, sorry, an old myth from village elders, essentially, that look, if everybody's looking at an elephant but they're blindfolded and they're too close to it, everybody's going to have a different perspective of it, right? So one might think it's a spear, one might think it's a rope. In our case, what I'm going to try and do here with this concept of a data pipeline is take those examples that I shared previously, take a step back and try to tease out the common elements that we as stakeholders within IT can actually use to build a resilient infrastructure where people can plug in their natural language processing use cases, their things from structured data sources, unstructured, and show what that framework looks like. The important concept here is the term data pipeline, right? So we'll start with that. From a simple view, regardless of what perspective and what use case we're talking about, an end-to-end data pipeline focuses on what's happening with data. It starts with the first box on the left-hand side of my screen that we refer to as IoT, right? I hear many things about the Internet of Things. Nice joke there. But basically, it's all about acquisition of data. And despite all of the acronyms that are focused in this space, from the various types of sensors, they could be video cameras, they could be click streams and things from websites. In many cases, locations, data from users' mobile devices. The biggest problem in the IoT space is just data acquisition, right? As data sources grow, being able to build them out, having a network that supports the transfer of that data and can route it to the right system is the big thing that we're talking about. In all of these cases, data is in motion. There's very little data actually being stored at the edge or in the Internet of Things that we talk about. The second layer of this generic pipeline we refer to as fast data is where data is actually ingested. In some cases, people refer to this piece of the puzzle as streaming analytics, the idea that data is being processed in real time. So either it's lightweight processing, it's routing to say which one of the various different systems or data storage devices it's actually being passed to. And in some cases, it's things like naming conventions, restructures, ETL processes. This is what's happening at this layer. Fast data is a little bit different than big data, which is the next one on our pipeline. And the idea is that the big difference and the big reason that technologies are split out into two different boxes here is because big data is all about data at rest. It's about batch analytics, offline analytics, reporting on the past, rather than real-time streaming analytics on what's happening right now. Big data that we've seen in the past has typically been fed with business systems, and the reason that I split out these two on this slide is to just say that in many cases, or in most cases, IoT data is semi-structured or unstructured data. Meanwhile, business systems provide structured data, databases, things that we're used to into the big data lake. But the idea here is that a successful infrastructure has a logical concept, whether it's a self-service portal like a ServiceNow or something, where data can actually be registered into a catalog and made available to users. Really important piece of the big data part of the pipeline. The fourth area and the last one in our really underlying infrastructure section at the bottom here is AI, is what people use to describe how models are being trained and developed based on all of this data. So assuming that we've gotten data from the left side in our Internet of Things, it's been ingested at the fast data layer, stored for long periods of time at the big data layer, tiered down to cheaper media when we don't need access to it. It can actually be used to train really valuable algorithms, things that need, dozens of terabytes of data just to be able to give an accurate representation of the problem you're trying to solve. That's done at this space in the AI piece of the pipeline. So of course, the loop closes when analytic models are finished being developed at the AI space. They're deployed back to the left-hand side of this pipeline, either to that fast data layer where you need to take a decision in real time, or actually out to the edge in the IoT layer. This is more common in things where data cannot actually be moved over the wire. So use cases like autonomous driving would fit in here. In some cases in retail banking, for example, security footage from video cameras may not want to be transferred, across the country to the main core data center. You want to take action on it in real time to determine something that's happening at the edge. Overall, the way to consume this infrastructure we refer to as having a data science tool chain. So being able to abstract away where data is. I was talking about the catalog earlier for big data. This also applies to things like resources, big memory machines, GPUs. It could apply to the tool sets that people are actually used to working with. I like PyTorch, you like TensorFlow. We can make that available at the data science tool chain layer and abstract it away from the actual infrastructure it's running on. So functionally, the next step is to figure out, what are the pieces that actually fit together to make this real. It's not slideware, what actually goes in here to acquire the data, what actually goes in here to store the data on the data lake, to make it accessible in a high-performant way at the AI space, and what are these business systems from BI to your ERP to HR systems, mail and exchange, additional data sources. I've been talking about clickstreams from websites, hugely useful in the space of customer retention. Social media and other unstructured data sources there are becoming very popular for using customer retention, as well as external data sources in this case for compliance and things like that from external entities. So the interesting part here and some of the connection to what I was talking about earlier with some of these use cases is to map, given logos from this big data space to what they actually do in this pipeline. It gets really confusing when you talk to, one of the many different logos in this space, and they've got the solution for everything, right? And bring all your data and we'll make it work. And the reality is that there's many different design decisions that need to be made, specifically on which application or which tool is going to perform the best, which is going to reduce my costs to store data, which is going to actually functionally do the thing my users need such that they can be productive. Mapping that sort of logo to the space across the pipeline that makes sense is a really important thing. And I've showed some on screen. I mentioned Data Robot earlier. Hopefully those on the phone are familiar with things like HDFS, S3 compliant object storage, Spark streaming, TensorFlow, PyTorch not shown on here, but many different logos to make some of these end-to-end pipelines actually work. And really no one logo to rule them all. That makes sense here. So how does HPE fit in, right? What do we have to actually provide in this space as sort of outside of some interesting use cases to talk about and some interesting customers that we can share experiences from? How do we fit in from a technology perspective, right? I talked at the very beginning about how we made strategic acquisitions of companies like SGI, Blue Data, Mapr, Cray. How are they actually manifesting themselves across these pipelines to make things real? Well, I'm gonna start in this space, the HPC and AI space at the end of the pipeline. But the reason I showed these slides was just to say, we do this stuff end to end, right? We are not a point solution that just fixes one problem with GPU performance. We're not just about the cheapest way to store your data, or the container platform that can give users access to new tools quickly. We do it all end to end. But let's focus on HPC and AI for the start of this, right? What do we actually do in the space of helping users, train models and then deploy them into production? Well, we essentially have a core compute portfolio that everything builds on top of, right? From the smallest, starter kits, where we have little bundles to get started, one single GPU on a ProLiant DL server, most popular server in the world, the DL380. Many of you hopefully are familiar with this on the phone, understand some of the management capabilities, and it's just a matter of getting a level of software and the right processor to get people off the ground and started. We do proof of concepts all the time where people are looking at trying to adopt some new tools or frameworks. I brought them up before: TensorFlow, PyTorch, MXNet. Taking that, wrapping it in many cases with software from the accelerator vendor. So NVIDIA, for example, offers a suite of containers that you can pull down and run on these platforms. We enable that and actually provide the support services such that if there's issues with the container configuration, if there's problems running it, you can call the support helpline and troubleshoot everything from the the drives and the components in the system all the way up to the Python code within that container, and figure out what the configuration issue is there. Beyond that, when you start scaling up, right, I'll jump straight over. I mentioned this previously. That exascale world, the Cray Shasta system, really proves that the technology that we have under the covers is industry leading, right? The 3 largest supercomputers that will be delivered later this year to the Department of Energy down south are all based on this architecture from Cray called Shasta. And the keys of this architecture can actually be brought into some smaller levels, right? We're seeing adoption of them in the financial services industry in particular, where people are seeing value in the Slingshot interconnect, in the end-to-end, Cray Linux experience, as well as in the space of high-performance file storage, being able to use a Lustre file system starting from as little as 115 terabytes, right? And providing the highest performance and the cheapest cost per dollar, or dollar per terabyte, cost per dollar per terabyte on that system with the Cray Cluster Store product. But right in the middle is where I think I'll focus a little bit more and talk about some of the interesting technology that we have here. The first is this system, the Apollo 6500 Gen 10, the most common, kind of our flagship product for supporting deep learning training and inference. Supports up to 8 accelerators, certified for the end-to-end NVIDIA software stack, and in many cases being used for workloads related to containers. Incredibly flexible, select to the CPU of your choice. From Intel, our next generation platform from AMD, supports NVMe drives, lots of storage so that you can treat this box as a high performance file storage tier as well, and conforms to enterprise standards, right? Real support, worldwide availability, and the HPE components that many people know and love, from our ILO out-of-band management processor and our embedded security on the motherboard. This system is a ProLiant, right? It's built like other HPE systems out there. Configuration choices. I mean, when you talk about deep learning, you talk about accelerators. We can provide them the envylink technology from NVIDIA that connects the GPUs together, or from PCIe GPUs, which is more of a traditional acceleration framework that we've seen really utilized for sandbox environments where developers or data scientists are looking to get a single container, single GPU. We can provide that very seamlessly with this system. The other one that's really interesting, and in particular really interesting for the financial services industry in the space of capital markets, is this system, the Superdome Flex. So this is a flagship product from Silicon Graphics that has merged with a mission critical product from HPE. back in 2017, 2018 timeframe, right after the acquisition, and has just been growing like crazy. So it's really a combination of the UV300 from SGI and the HPE Superdome X. People view this as a mission critical box, but we've seen financial customers get serious benefits from this because of its scalability. So when you think about high performance computing, the easiest way to think about it is that it's a scale out architecture. When I run out of space in a single node, I've got two processors, I've got 32 slots for DIMMs. I can get up to like 4 terabytes of memory, something like that, and maximum, right, 24, 48, up to 64 cores. I think now is what we've seen people really using within a single system in HPC. What if I need to go beyond that without adding more systems in a scale out manner, but actually scaling up such that I have a single operating system, a single deployment of Linux, and it can get access to essentially scale units that have 4 sockets in them. So you'll see my picture on screen has 8 boxes on here. These are all 4 socket systems that have been connected together. So the total system is actually 32 CPUs, 32 sockets all working together, all with access to every single DIMM, all 96 terabytes of memory, main memory in that single operating system, that single instance of Linux, in under 400 nanoseconds of latency. So we have seen, our largest customers focused on quantitative analysis in capital markets actually use these systems for real-time, speed of light trading, right? And taking advantage of that response time to run that analytics. So in many cases actually rewriting their applications, designing them for this system specifically, because there's nothing else like it in the industry, right? Again, 48 to 96 terabytes of main memory in a single operating system, or lower, starting with 4 terabyte building blocks and going up from there. Okay. So the next piece to talk about here is actually moving on from the compute side and talking about those data science tool chains. I'll get through this pretty quickly because we really have too much to talk about here, and it warrants another session if anybody on the phone is interested in it. And we've made some really interesting announcements just last week and 2 weeks ago at our virtual Discover event, which is a yearly conference that we put on for our customers. The big thing is that HPE software is back and it's here to stay, right? Our global chief technology officer, a guy by the name of Kumar Srikanti, former executive at VMware, used to run R&D there, and most recently founded a company called Blue Data that we acquired in November of 2018, is now responsible for setting the strategy of HPE going forward. And specifically, the number one thing that he's doing is focusing on containers. So Kumar has set a direction that, look, the influences from Blue Data are going to grow as containers really become the next wave in software development. And specifically, the way in which Blue Data has built their product and how we're evolving it has always been focused on artificial intelligence, right? In the past, people referred to it as, advanced analytics for big data. But the idea is that our new product we're calling the HPE Container Platform. It's a part of a HPE Ezmeral, which is our brand for our software business unit, and which is led by our global CTO, Kumar, who reports to our CEO, right? He's the guy for technology strategy at this company now. Really brings together these 3 logos on screen. So I've been talking about Blue Data a lot. It is essentially a container platform that's been around longer than Swarm, longer than Mesos, much longer than Kubernetes, and has been exclusively focused at the start really about providing Cloudera services for financial institutions. I need to run something with bare metal performance quickly. Well, the only option was containers, and Docker containers have grown in influence and more across the big data space, and of course across AI as well. The other two components are Kubernetes. Over time, Kubernetes has emerged as the standard for orchestration. Really doesn't break any of the value from Blue Data. So we've ported over the value that Blue Data has provided around persistent storage and prepackaged applications. So things like Cloudera, Spark, Hortonworks, Kafka, TensorFlow, Jupyter notebooks with TensorFlow and PyTorch loaded into them, with the GPU drivers. All of these things are available through this platform. It can be procured in a self-service way, and now they can be orchestrated with Kubernetes. Also bringing in external Kubernetes resources. I'm going off on a tangent, but suffice it to say, there's a lot to talk about there as it relates to containers and their applicability for AI. The last comment to make is this company, MapR. So for those who aren't familiar with MapR and really the Hadoop space in general, MapR was essentially the third horseman in enterprise Hadoop world, right? The Cloudera, we had Hortonworks, which were implementations of the basic Hadoop distributed file system, HDFS from the open source community, whereas MapR actually created an extension of that was more performant, more scalable, and much more functional as it relates to data access and being available as a native Linux file system. So the technology from MapR we acquired last year and around this time, and we've integrated within this platform such that if you license a container platform from HPE, you by default get access to all of the great things that MapRFS brings to the table and can start building out a really incredibly scalable and performant data lake for any net new data that's been brought to the platform, or integrate it with existing data sources that you have using our data tap technology. So with that, just a few more comments on the container platform to say that there's a ton of differentiation. We're really excited about the future of containers, their applicability for artificial intelligence and machine learning, and the fact that we are taking a different spin on Kubernetes, focusing in on data-driven workloads, and really have a lot of value to bring there. From experience with customers like global financial institutions that have been working with us since 2015 on this platform in production. Right? So with that, Brian, I think we'll close it out on the formal presentation piece and try and get through some Q&A.
Thanks, Jordan. Just as a reminder, I haven't seen any questions come in through the chat at this point, but we did receive a couple questions ahead of the presentation, so maybe we can start there. Jordan, do you want to talk about any additional information around kind of chatbot development information? That was one of the customer questions that had come in.
Absolutely, yeah. So we see chatbots kind of two different ways, especially in financial services. One is the way in which we can provide sort of an end-to-end solution with a software vendor that's created a chatbot for a specific purpose. So in many cases, the users, at that institution that are evaluating chatbots will, bring a software vendor and say, look, we want to work with these guys, we want to evaluate them, or we want to do a POC testing, a bunch of different ones. Can you get them access to existing data sources, or is it possible to containerize their applications so that we can spin things up, spin it down? We engage in that way. Alternatively, we have seen many use cases for chatbots and the applicability specifically for an AI technology referred to as natural language processing, where people are inputting data in free-form text ways, right? So they're typing in to the chatbot, and you want to actually be able to promote certain chatbot interactions to a human level, right? So for example, in the space of customer retention, one of those data sources that I was referring to on that slide may be somebody actually going on a website, clicking around to certain things, you're tracking their click streams, and then as well chatting with an agent or a virtual agent, such that certain things in the text are promoting a feeling that this person may be at risk of defecting to a competitor, or in the case of customer acquisition, maybe a good opportunity to actually to actually engage with and provide specific, targeted marketing materials. So in this case, the space and the technology underlying this is actually a inference engine, right? So the idea being that that a model has been trained to promote or demote, certain inputs, certain queries that are not just based on keywords, right? So just because somebody said bad doesn't mean they think it's bad, right? They could be saying badass or something like that. It's a classic example in the space of natural language processing. So being able to build those algorithms, deploy them in real time, train them, and then correlate them with other data about those customers in the case of customer engagement, it's a really complicated end-to-end process. And we'd suggest that, in this is not slowing down, right? So chatbots are kind of an implementation of what I was talking about related to customer engagement in some spaces. And yeah, really good example of how at the user persona layer, or the from the customer's perspective, how AI might actually be presented to somebody.
Okay, great. We actually just had another question come in on the chat. So first they said terrific presentation, Jason. So great job, or Jordan. So great job there. And then, are you working on a solution or partnership with NVIDIA using DGX systems?
DGX systems, yeah. So I went through the Apollo 6500 there. That is essentially a system that we co-developed with NVIDIA when they were building their DGX systems. So that would be for customers who are used to HPE, want that flexibility of picking a CPU or different storage devices. You could go with the Apollo 6500. For the DGX side, if you have existing resources from NVIDIA, we absolutely, we have reference architectures for our storage that we're working on to determine how we can actually drive the best performance out of those GPUs, because we do have the most performant file system in the world, starting at 115 terabytes with Cray Cluster Store. But then in addition to that, how we can enable these DGX systems to, accept workloads and get access to data. So I talked a little bit about the container platform. We have plenty of customers who, like our storage, they want to be able to enable that end-to-end experience. And so they take the container platform and they use technology like data tap to get read-only or read-write, credentialed access to existing data sources that are not running on that DGX, but are useful for work that's being done in the AI space. So yeah, we have the HPE DGX 6500, and we do see lots of them out there, and work with NVIDIA quite closely for customers who already have those DGXs as part of a lab that they're building. Sure.
Okay, so we're coming up on the top of the hour. Maybe we'll wrap there. As a reminder to everybody on the phone, if there's any questions or subsequent conversations that you'd like to have with the HPE and CDW team, please reach out to your account team, whether you're account executive or your account manager. I want to say a very big thank you to Jordan Nanos for spending some time running through what HPE has to offer. I thought it was a fantastic presentation, and I'm sure I'm not the only one. Maybe just to end, want to highlight, the fact that CDW and HPE, whenever we get a chance to get together, whenever we get a chance to partner together, it's one of the most remarkable partnerships that we have at CDW, one of the longest standing partnerships that we've had with all the different partners in the ecosystem. It's a partnership built on trust, built on, respect of our customers and delighting our customers. Pre-lockdown, I was at an event last year where our CEO at CDW and Antonio Neri, the CEO of HPE, got to host about 40 customers, and it was really amazing just to see the powerhouse of the HPE and CDW partnership. So with that, big thank you to everyone who's joined. We hope that this was informative. We hope that you got a lot out of this presentation, and we look forward to talking and seeing everyone shortly. So with that, have a great day, and thank you for attending.